We will go to the end of time today, folks, so be ready. And I might mean that by literally, by the time we leave, you'll feel like it's the end of time.
Well,
I feel like that every class.
6 of us.
All right, so data.
Who needs to know how to count? What?
So normally, folks, when you get data, data shows up in what we call a comma-delimited list. Why is it a comma-delimited list? Because the list of numbers are separated by a comma, right? So you've got stuff like 2, 4, 8, 12, 25, right? Comma-delimited list of data. Now, sometimes having data like this is good because it's kind of obvious to see what the information is right here because there's only 5 numbers in there, okay? You can run into situations where your data in a comma-delimited list is really, really, really unfortunate. So something like this.
2,821, comma, we get the point.
Etc., etc., okay? So the list is basically a bunch of numbers, and there may be a bunch of repetitive numbers showing up in a row, right? And so you may have like 6 1s, 8 2s, 7 3s, 16 4s, etc. And so instead of getting the data in a comma-delimited list, what do you get your data in? A frequency table. What a frequency table is just a table that combines all of the numbers that repeat. Okay?
So it shows you get like 4 1s.
Uh-huh, exactly. Alright? So it's just a table with 2 columns, data and frequency. And so if you had 4 1s, your data is a 1, the 4 just represents how many times the 1 repeated. If you had a 2 and you had 7 2s, that's like writing 7 2s. That's way the hell easier than writing 7 2s, right? And likewise down the row, right? So maybe I gave out a 5-point quiz in one of my classes, and these were the grades on that 5-point quiz. So everybody got at least 1. Which is good. But maybe there, in theory there could have been zeros in there, etc., etc., okay? So one of the things that you will deal with when dealing with data in a frequency table, folks, is first of all, notice what order I put the data in. The correct order. I didn't go 1, 5, 2, 3, 4. Please, if you ever create a frequency table, put the numbers in order. It doesn't have to be from top to bottom. I mean, it could be from bottom to top or top to bottom. Either way is okay, but just be consistent, okay? Just don't hop around when you're creating a data table. That's really frowned upon out there in the real world, okay? So, you will do these sorts of things, though, folks. It's part of life, all right? Now,
Not my life.
really? You don't think so, huh?
So,
You sure?
I feel like it's about to be part
You
of
don't
it.
think you're ever going to have to deal with data in your
you
life?
have to understand, I'm almost done with this.
This is exactly what they're throwing at everybody right now.
I
Is
know.
keeping track of data, right? It's happening everywhere. I don't care where you are; they're keeping track of it, right? The scary thing is like if you're a UPS driver, they actually have little monitors on the entire truck that track how many times you turn left, how many times you turn right, how many times you stop, how many times you open the door, how many times you unlock the seatbelt. I mean, all of that's tracked all the time.
I work for UPS, and like the scanners, that every 10 seconds it sends a message to the.
Yep. For everything that you did, right?
Yeah,
Like, what's your speed that you're driving right now? Boom, it's sent there.
Yeah.
Are you kidding me?
No.
Yeah.
Diane's car actually graded you on your birthday.
See? These are the sorts of things that's going on. So you may think you're not going to have to play
I
with
don't
data.
want to.
You're going to have to, Greg. Even as old as you and I are, we're going to have to deal with it.
UPS drivers drive like a bat out of
right, so what happens if we get a slightly different set of data? So let's suppose we get grades on a test, okay? So those were quiz grades. These are test grades. So the test grades were like 95, 82, 77, 67, 87, 91, 55, 41, 92, 86, 71, 65, 62, 54, 77, 88, 95. All right. So let's suppose this is a set of test scores for one of my classes, and I want to show the data to someone else so that they can look at it. First off, does this look nice? No, yeah, it kind of sucks. Would it be a good idea to create a table like I just created a second ago? Why not?
Because there's one of every, like, different numbers.
Yeah, I mean, you would just be basically giving them the same numbers, except it would be in a table instead of separated by commas. So what do we do instead?
Means both.
We're getting there. Hang on. Sometimes when your data is a little bit more disparate, when it's a little bit more spread out, you create what we call a grouped frequency table. And a grouped frequency table is just a way of getting essentially the same type of table we just had a second ago, something that's relatively compact. But in order to keep this compact, we have to group numbers together. Now, since these are test grades, what numbers do you think I should group together?
90 to 100.
Uh-huh, exactly. So you create a range of data in each one of your rows, 90 to, let's say, 99. And what's my next row going to be?
80 to 89.
80 to 89. And when you create one of these grouped frequency tables, once you set a pattern for your rows, it has to stay the same from row to row to row to row. Okay? So every row after this, folks, what do I have to do? Same thing, okay? And did I write any 40s up here? Yeah, I did, because it always happens to me.
That's shitty.
I feel like that always happens.
Yeah, it means I need to use corporal punishment more often. So that if students are not scoring well enough, I should be able to take a ruler and just say, "Put your hand out," smack, and then they won't get 40s anymore after.
No,
Would that
drop out.
would that work? Yeah, okay. Okay, so now how are we going to figure out, folks, what the frequency of numbers are that are between 90 and 99?
Count them.
Count them up. Hey, what do you know? So how many 90s are there, folks? 4. And what you might want to do if if you're kind of old school, like maybe I am, you would say, oh, count them while you're going, right? I see 1, 2, 3, 4, right? You have 4 little hash marks at the end. Yeah, frequency is 4. How many 80s are there, folks? 4. And again, it's not necessarily a bad idea if you're actually doing this kind of thing to actually cross out the data while you're going, just in case, right? I mean, it's not something you have to do, but if you don't want to accidentally double count a number, you should really scratch them out while you're going, right? So how many 70s are there? 1, 2, 3. How many 60s are there?
3.
50s
2.
and 40s.
1.
Okay, so just realize that this is sometimes what you have to do in order to get your frequency table to look nice, and hopefully the ranges of data are actually meaningful, right? And the meaningfulness for these, you guys would know, right? I mean, what are the 90s in my class?
Age.
These are the A's, right? What are the 80s? B's, C's, D's, and belows, right? And so these are the sorts of things that you would somehow want to be able to display in a table or in a graph when someone wants to see your data, right?
Put it in Excel.
Exactly. What would Excel do?
Do it for me.
It would do it for you, but what if it didn't do it very well for you?
Then I guess I'll mess it up.
All right, so folks, what types of graphs would you create for this data?
Bar graph.
Bar graphs, line graphs. Okay. Generally speaking, just so that you know, it's usually assumed that the frequency goes on the vertical axis or the y-axis, and that the data goes on the x-axis. It doesn't have to. You can flip those around. You can have your bars going horizontally instead of vertically. But generally speaking, most bar graphs are done vertically, going up and down, instead of horizontally going right and left. Don't have to do that, but again, you can be a rebel if you want. So for my graph, there wasn't a whole lot of information. There was only ever 4 frequencies in any group. Again, be careful, folks. I put the data from 90s down to the 40s. If you're creating a table, or if you're creating a graph, should you start at the 90s and then go down? That's not normally the way a number line works, right? A number line grows as it moves to the right. So in theory, when you graph this, you should really have your 40 to 49s first, and then your 50 to 59s, etc., right? 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99. Grades, right?
Data.
And then you create bars, that you guys know how to draw a bar if you have to, right? So there was 140, there were 2 50s, there were 3 60s, right? How many 70s were there? And then 4 4. And note, when you create bars that are touching each other like this is called a histogram.
Do you need to know that?
Not really. But realize the difference between a standard bar graph and a histogram, okay? A standard bar graph, the bars are separated. A histogram, the bars are together. Does it matter which one you use? Not really. But some people will tell you, well, I wanted a histogram, because they're all snooty. And you just have to know that that's what this means, okay? Now, folks, how do I tell people that inside of these data, there's actually more information, right? That these represent A's, these are B's, these are... How do I give that information to my readers?
Put it above the bar.
You could potentially somehow mark the bars or mark the data down here, but what is the standard accepted method of doing this?
Colors.
Is using a legend.
Arrows.
And please don't use colors, because unfortunately men are 15 to 20% colorblind. So instead of using colors, what are you supposed to use now?
Color blindness is not the only thing that men lack in.
I won't go down that road. I won't disagree
I'm
either.
so confused right now. Like, I don't even know.
They're supposed to use like lines and.
Exactly.
No, I meant like. No, never mind. I meant the whole men being colorblind thing.
No, 15 to 20% of all men are colorblind.
Really?
Yeah, and only between 4 and 5% of women are.
That's because we're better, but
Exactly.
Yeah, it's a Y thing. It can happen in the X's, but it happens very less often. All right. So, anyways, when you create legends where you need data, right? So you create patterns, and then over in the legend you say, oh, this is a pattern, and these represent the letter grade A. So this is how you give additional information to users if there is a need for it. Okay. You could put down below here that these are A's and B's and C's, and it's okay. But a legend is much cleaner. Putting it with the numbers is a little tacky, okay? Again, it's not a super big deal, but it's just good practice to use good graphing techniques when you go to present data to anybody, okay? If you have to present data, and when I was working at Epic, the number of times I created a bar chart using Excel made me want to barf, to be honest.
Because they go like sideways.
Yeah, I mean, some of them will go diagonally, right? It's whatever. But I mean, the idea is that you should definitely be using these sorts of things to present data to other people, right? And you can get carried away if you want, right?
Little stars.
Exactly, or little smiley faces, right? I mean, granted, I shouldn't do smiley faces for the D's, but, you know, so
Would
the
this
F's.
count as a picture on the test?
What?
Would this count as a picture on the test?
Like a star and an F. I think that's a little, you know,
And then potentially you might have
Frowny
your
face,
frowny
yeah.
face, right? Yeah, and maybe this one you actually do something like really bad, right? Whatever. I mean, again, the idea though is do not forget that to get additional information on a graph, a legend is really the best way of doing it. Okay, and it's a lost art. This is not something that's used very often, and it's unfortunate because it really is the nice and clean way of giving that information. And again, depending on the people that you're giving this data to, some people might care more about the numbers, and so you'd show the numbers here, and other people may care more about just the letter grades. And so you may swap the data between your legend and the actual label and say, well, these were A's, B's, C's, D's, and F's, and oh, here are the numbers that those represent, right? I mean, that, depending on who you're sending information to, you may switch those sorts of things. And again, just do it when you need to, all right? All right, now, I assume I don't, how would I make this a line graph, folks?
Make a little dot where the numbers meet.
And what would I do with the dots?
Connect them.
Woo-hoo. You will do some homework problems where I ask you to draw bar graphs and line graphs, folks. Just don't screw them up, right?
Line graphs off.
I'd rather do bar graph.
No, it's off. Don't try to even
Off
sit
why?
here and tell me. Because where you drew your tick marks for like the actual 40 to 49 is actually the end of the bar.
Exactly. Those are the ends, right? And so when you do a line graph, you do it always in the middle of the bar, if it's a histogram. Because these are ranges, right? So this is 40 to 49, so you use one dot to represent the middle of 40 to 49, which is basically like 45, etc. That's the idea behind that. So I don't want to sort of beat the bar graph and the line graph to death, but I do think that these are lost arts that you should be able to utilize when you need to. And if you just use Excel to do it, I'm okay with that, just as long as you know how to potentially get the legend to pop out in Excel, if you need it, right? If you do, great, use it. Then we're all good. All right, now, those are graphs that are nice, but the graphs that I really like,
Probably the ones that we're going to have.
which,
Probably pie graph.
why would I care more about pie graphs?
Oh my gosh.
Pies.
because pies are always going to have a percent associated with them. And what do I care about all the time in this class?
Percentages.
Percentages. Hey, what do you know? So pie graphs are a little bit more common for dealing with life in this class. And again, if you guys can create a graph that's a nice three-dimensional pie graph for a business meeting, you're the bee's knees. You're the cat's meow.
Yeah.
And it's meant to sound old and corny because it is, but pie charts, three-dimensional, make everybody feel happy, right? Because they see numbers, but they see numbers in pie, and then they think, oh yeah, it's Thanksgiving, pumpkin pie. Or they think, oh yeah, it's close to Christmas, cherry pie.
Sweet potato pie.
Exactly, right? Pecan pie, whatever your favorite pie is. Anyways, okay, so let's do a pie graph. Let's suppose that I worked for a department store for a summer, okay? And I was selling stuff. So, what sort of stuff do I sell in a department store?
Clothing.
Clothes. What percent of my sales were clothing?
87.
Yeah, that's probably.
Okay, so let's suppose that clothes were 15%.
That's not even close to
How do you know? Maybe I was mostly in the electronics department. So what else did I sell in the department store?
Shoes.
Shoes. What percent?
10.
Hey, good number.
You're welcome.
10% shoes. Okay. What else does I sell?
Electronics.
Electronics. Let's assume that was mostly what I did, right? 25% electronics. All right. What else did I sell?
Hygiene.
Hygiene.
Well, like bath stuff. Like
Okay.
shampoos and
So what percent would be my bath item?
products.
yeah, health products. Healthcare.
Health. Okay, that sounds much better. I like health products. Let's assume that I did 20% health products. We need a couple more here. Let's see. What else did I do?
Furniture.
Furniture. Okay, furniture always is a relatively big one. So let's suppose I had 25% furniture. Furnitures, no, just furniture. And then last but not least, a 5% miscellaneous, right? Random stuff. All right. If I told you that my total sales for the summer were, say, well, probably I'm not that good of a salesman, right? $2,000.
That's it.
Yeah, I saw.
Just give us.
Does
For a
it-
year?
No, for a summer.
Oh my god, I did that in a day.
See, you're better at this than I am.
Probably.
All right, so what sorts of questions am I going to ask, right? So, types of questions that I can ask are, what percent of my sales are shoes?
10%.
Yes. Folks, if I ask you for the percent, please give me the percent. If you want to calculate how much money it is, that's great. What did the question ask for, though?
Decimal.
The percent. I didn't even ask you to give it to me in decimal form, although I would love it if you did it. You know that, right? All right, so you would say, good, 10% of my sales are in shoes. All right? So, let's see. How about another question? How much more money did I sell in electronics than, what was one of those other ones? Clothes. Now notice, what did I ask for this time?
Money.
Money. Now figure out the money, folks. All right? $200. Why?
Because 25% of 2,000 is 500, and 15% of 2,000 is 300.
Electronics, 0.25 times 2,000 is, what did you say that was?
500.
500. And then you did clothes. 0.15 times 2,000 is 300. Figure out how much you sell in both one of those. So remember that you know what those bar graphs mean, right? What the pie graphs mean. Take the percentage of the total to figure it out. So a $200 difference. How else could have you done this problem?
The difference is 10%.
The difference is 10%. What's 10% of 2,000? 200. Okay? That one actually still works, right? Because we're taking those percentages, both of the same number, 2,000, so literally you can just subtract the percentages. That's the only time that you can, when you're taking the percentage of the same thing, right? All right, so now let's have a tricky one. All right, let's suppose that I had an additional $500 in sales of electronics that was not included. So when they tallied up all of my receipts for the 3 months that I was being a salesperson, they had an extra $500 sale that they didn't notice until after they had generated all their data. Right? So, what is my new percentage for electronics? After I add this $500 in.
Wow, you're tricky.
Well, that's a good type of problem, right? Very real worldly type thing.
So you would have to come up with a new percentage for electronics now.
Well, technically, I would have to come up with a new percentage for
Everything.
everything. Why everything?
Because your pi should equal 360. No.
That's
100.
degrees.
100%.
It still has to be 100%. But why do all of the numbers change?
Because if the electronics goes up, the other one's got to either go down or whatever, because you can't go, it's got to be 100%.
Okay, so what do I have to do with that 500 besides just putting it in electronics?
It's got to go spread it out all the other ones, doesn't it?
What were my total sales, folks?
Now it's $2,500.
There's the key, right? That $500 doesn't just go to the electronics box, it goes to the total box as well, right? If they missed that number, it was not part of the total. Therefore, you need to add 500 to electronics and 500 to the total. And that's why everybody else's changes, because now the basis of all their percents, which used to be 2,000, are now 2,500. Okay? So that's what you have to be a little bit cautious with, right? So you have to say, total is 2,000 plus 500, 2,500. So now your percentage is going to be out of 2,500 instead of 2,000. Now, what number? How much sales did I have in electronics?
With the new one?
Yeah.
625.
Why?
Because it's still 25%, right?
But it was 25% of what?
2,000. Oh.
It used to be 25% of 2,000. So how much were my electronic sales before this new 500 got added in? We already did that one. That's kind of why I went back to it.
500.
It was 500. So what are my sales in electronics now? 1,000, right? Okay? So definitely got to make sure that you add the total to the electronics bucket as well. And now, what percentage is that? 40. How'd you get that?
I divided the 1,000 by 25.
All right, exactly. So the new percentage equals 1,000 out of the 2,500. Nicely enough, that was 0.4. And having immediately said, hey, I know what that is. That's 40%. All right? Not bad? So now that you've seen that one, how would you tell me the new percentage for close is?
Wouldn't you just subtract the 1,000 from the 2,500, and then that's what you have left for total for all the rest?
Okay, but I want the new percentage of close based on the new total of $2,500.
Well, it was what, 300?
Ooh, it was $300 before. No, we did close once. It's $300. And it used to be 15% because it was $300 out of 2,000. What is it now?
Or 500 or whatever.
What's the new total?
1,500. Oh, I thought you would have to subtract the 1,000.
Yeah, that's what I was thinking too.
But I want the new percentage for close out of my total, not out of what's left.
12%.
Right? Right? Because all of those percentages have to add up to 100%. You don't take this out to figure out what it is as a percentage of the total. You just take the percentage of it as a total, right? So close used to be $300 out of $2,500. You get 0.12. Which you tell me is 12%. So what did close used to be?
It went down.
15.
Down
It went
3%.
down to the 12, right? And so this is how it works, right? It's not a straight shift. You have to take each number and recalculate the percentage based on the new total. Okay? Okay, so now you guys are making me nervous, so you're going to have to do another one.
Makes sense.
Because life is painful, deal with it. All right, so how about the new percent on health products?
What was the old total?
It used to be 20%. We never calculated the total. It used to be 20%.
Would you figure it out by going back to the old 2,000
16%.
and subtracting the, what,
Yeah.
800 that was your electronics and your clothing, and then find out what percent of
I want the new percentage of healthcare products as a total of $2,500 sales.
So you take the 20%
20%
times 2,000.
times the old $2,000 amount. What does that give you?
400.
And what does that represent?
Then you divide 2,500 into 400.
But why? What is this 400?
That is what it used to be.
That and still is, right?
Right.
It's my total sales in health products is still $400 because I didn't add or subtract anything from it, right? So it's still $400, but that $400 used to be out of 2,000. Now it's out of 2,500. So to get its new percentage,
And divide it.
yeah, you divide by the 2,500. Which you get 0.16, and turns out to be 16%. So that's the idea, is that each one of the other values, each one of the other pies, its number stayed the same when it came to the $2,000 to begin with. But now you have to take that old number and divide by the new total, 2,500, for every one of those percents. So, watch for that, all right? Because this is the kind of stuff that I like to throw at you so that you can remind me that you know how to do straight percentages, right? Because this is really a straight percentages problem. And it's a very common straight percentage problem to deal with, okay? So this will be a test question, not subtle hint, okay?
Oh, what a dumb guy.
Now, I may change it up a little bit, right? So
No,
instead of
why would
having,
you do that?
$500 new dollars in sales, I may say that it's,
425 or something stupid
or,
thing.
no, I'll say something like there were $200 less, or there was a shift of $200 from electronics to furniture, right? And so you'll have to basically redo those numbers based on whatever I tell you happened,
Or a
okay?
7% decrease.
Yeah, because think about getting a 7% pay cut and then having to readjust where you spend your money, right? And so if I say it all gets taken out of this bucket, blah, 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 right? And that's a very common sort of thing to do, is to say my household budget is this number of dollars, and this is where I spend it in a pie chart. And if you then have to take a pay cut, you have to figure out where the money's going to get subtracted from, and then the pie chart completely changes. Total real world life stuff, okay? Alright, so anyways, do not be surprised when you see a pie chart on the test next week. Alright?
Kind of looks like how you would cut your pizza.
I love weird cuts on my pizza. Those are the best. Alright? So, anyways, be ready for that. Not bad? Alright. So, measures of central tendency, said in a very snooty tone of voice. This is just the title of this section, okay? One of the standard measures of central tendency that we work with is the mean. What's the mean, folks? What's another name for it?
Average.
Average, right? Why don't statisticians use the word average? Yeah, absolutely, right? If you say the word mean, what does it sound like, right?
Mhm.
Yeah, it's an important word, but if you say the word average, what does it sound like?
Just plain.
Yeah, it sounds like average, right? So who would want to use a word that just sounds dull, right? So, especially when you're a statistician who, by definition, is dull.
Average. Boring.
All right, so how do you calculate the average, folks?
Add them all up and divide by how many there are.
Sum of the numbers divided by the number of numbers. Anytime you can have a sentence that has the word number in it 3 times, that's a kick-ass sentence. Welcome to math. Now, what I like to do with you guys here is to get you started on statistical notation, just so that you can get used to it, okay? If you take some statistics later on, you will definitely have to deal with it, so it's a good first introduction. The mean in statistics tends to be a letter with a bar over it, okay? It can be X or Y or A or something along those lines. Whatever letter they use to represent the data, when they're talking about the mean of the data, they will put a bar over the letter. So if the data is called X, the mean of the data will be X with a bar over it. And it's often called X bar. Now, the way you calculate this, folks, the way I will show you how to calculate it. Sum of the numbers. This is how statisticians write the sum of numbers. What is this symbol right here? You guys ever seen that? What?
It's an M that fell over.
Kind of. It's actually a Greek E is what it is.
It's probably like some zeta.
No, I was about to say I wasn't in a frat, so I don't know that.
It's a capital sigma if you want to know. Don't worry about it. That's not all that important. But you should recognize this symbol if you've ever used Excel. What does this symbol do if you push it in Excel?
It equals everything.
Yeah, it sums things either up above it or off to the left. It's a standard button that says the sum of. Okay? So this symbol means the sum of, and then whatever follows it is the stuff that you're adding up. X is the numbers, so that symbol, sigma X, is the sum of the X's. Alright?
Is this going to be on test?
No, but I'm going to use this later on to describe standard deviation, so it's important to get it now. Now, after you add the numbers, what do you do to get the mean?
Divide by how many there are.
Divide by how many they are. Standard notation for statistics, folks. Lowercase n represents the number of numbers. Okay? Anytime you look at a statistical report and see a lowercase n, that's telling you this is the number of data points, the number of people we sampled, or the number of numbers. Okay? So just realize that n is always that. It's very, very common in statistics, so it's good to see it sort of drilled into you. All right? Now, the reason I show you this is not because you need to know it for the test, but because I'm going to use it when I talk about standard deviation and how we calculate that. And knowing this will make it easier. All right? Please realize that, folks, you know how to compute the average. Okay? You add up the numbers, you divide by the number of numbers. It's the same as the mean. Okay? Now, the second measure of central tendency that we work with is the median. What's the median, folks?
It's the middle of all your data.
Yeah, the middle. It's the thing you don't drive over when you're on the road, right?
I mean, sometimes you
Yeah. It's bad, though.
do. Depends on where you're going.
True. Middle number. Now, why is this mildly a problem, though, folks?
Because if you have 80 numbers, you're not going to sit there and cross one off on each end to get to the center.
There are two cases we have to worry about.
You have to put them in order, don't you?
First off, they have to always be in order. Please, please, please do not calculate the median without putting the numbers in order first. And the order, whether it's smallest to largest or largest to smallest, doesn't matter, just as long as it's in order. Okay? But now there are two cases. Why does odd n or even n make a difference?
Because if it's even, it's going to have two of them.
Exactly. When you have an even number of numbers, there isn't one number in the middle. If you have an odd number of numbers, you will. You'll have exactly one number in the middle, right? Exactly one. And the position of the middle number will always be n plus 1 over 2. I will show you why that's important in a little bit. Okay?
I still wrote them all out. There.
If I give you 500 numbers, are you going to write all 500 numbers out?
You won't give us 500 numbers.
You know how much of a jerk I am.
You did it in college math. I sat there and wrote them all out.
All right. And it's okay, right? I mean, it is okay, right? So if there are an even number of numbers, folks, there will be two middle numbers, okay? And the way you find the median is actually by averaging those two numbers together, all right? So add the two numbers together, divide by 2, okay? And the cool thing about this is the position of the numbers in the middle is the halfway point in theory, right? So if there are 40 numbers, the two numbers in the middle are going to be the 20th and the 21st numbers, okay? Because 40 divided by 2 gives you 20, and one more than that gives you 21, okay? And this will make life easier when you start dealing with large number of numbers in a frequency table. Yes, Monroe?
Oh, never mind.
You got it?
Yeah, it was just on the main screen. The equation was cut off.
Oh, really? Weird.
Yeah, but it's not full on the screen.
Okay.
What did you say? N over 2, and is it an and or add?
And, yeah. And n over 2 plus 1. All right. So, not bad? So, really quickly, what's the median of that set of numbers? 7. Why was that so easy?
Odd number.
Yeah, because there's only 5 numbers and it's really easy to see the number in the middle. Okay, so what's the median now?
11. Sure. Is that right? Yeah. What do you mean no?
No. What's the median?
Oh, it's 7.5.
7.5. Because what are the numbers in the middle, folks?
7.5.
7 and 8. When you add 7 and 8 together, 15. Half of 15, 7.5. Okay?
That's because I typed it in my calculator all at once.
Yeah, you did 7 plus 8 divided by 2. That's 7 plus 4. That's
Yeah.
11, yes.
I mean, it sounded weird in my head, but I was like, hey, calculator's not wrong.
Yes, calculators are always wrong, but it's PEBCAC. That's the problem, right? Problem exists between keyboard and chair. You guys ever heard that phrase?
Yeah.
Yeah. It's a classic phrase for a computer science person. Alright, so anyways, you have to be able to deal with these, okay? And we'll deal with some problems where it will be more painful than being able to write them all out. Alright? Oh, 3. Our third measure of central tendency.
Most.
Mode. And what's the mode?
Most.
Yeah. Most frequently repeated. There are some conditions to the mode as well, folks, so please be careful. If all of your data is unique, if every number is in your data set is a different number, then the mode is that there is no mode. And not 0, okay? 0 is a wonderfully nice number. In fact, it's my favorite one, right? So if you have no numbers that repeat, the mode is that there is no mode. And note, folks, you can have more than one mode if more than one number repeats the most frequently, okay? If more than one number repeats the most. So if I give you this set of data, so let's suppose I give you these numbers, 1, 1, 1, 2, 2, 3, 3, 4, 5, 5, 5, 6, 7, 7, 7, and say what's the mode of that set of data?
1, 5, 7.
Yeah. Do not do anything with the 1, the 5, and the 7. You do not add them and divide by 3. You don't multiply them and divide by 12. You just write them all down. They are all modes, okay? And again, note, 2 and 3, not a mode. Even though they repeat, they did not repeat the most. Right? The most repeating is 3. Those only repeated 2, hence not modes. Okay? So, not bad? Okay, so. Find mean, median, mode. How do you find the mean? Add them all up, divide by the number of numbers, which happens to be 6. You add all those numbers up, what do you get? B is 7. What's the median?
6.
6.5.
6.5. Why 6.5?
Because you have to put them in order and then put them together.
Oh, damn.
Don't forget to put them in order. 2, 4, 6, 7, 8, 15. You know I'm going to give you the numbers out of order once, right?
Yeah.
You know that's the kind of jerk I am. So, and that's the level of jerkness that you should expect from me too, right? I mean, I'm not going to give you numbers that are insane, like 4.2 and 6.35 and 1.2278, right? That's not the level of an asshole I am. I just give you the numbers out of order. Yeah, all my numbers are
Begs to
nice.
differ.
So,
I feel like it's a trap.
6 plus 7 over 2. The median is 6.5 because again, there's an even number of numbers, so both of them are in the middle. And last but not least, what's the mode?
There is no mode.
All right, good. So please write the phrase "no mode."
You
Okay.
can't just put like none.
I'd be okay with the word "none" as long as you wrote the word "none." Yep, I'd be okay.
As opposed to writing what for none?
0.
Zilch.
0. Yeah.
Nada.
If you wrote the number 0, I would mark it wrong
Nada.
because nada. I'm okay with that.
What,
That's
what
it.
if you do the 0 with the slash in it?
As long as you can differentiate the 0 with a slash through it and a regular 0, yes. I'm okay with the
I
empty
just need
set.
to know the parameters, going into this thing.
Can we write in German?
Ah, ja. Sprechen Sie auf Deutsch? Ich bin ein.
I know a couple words in German, but
Yeah, we don't need to know.
I feel like they're probably not part of that conversation.
All right, so how about if I give you this set of information? So let's suppose that I had a frequency table. And here's our data. 6, 5, 4, 3, 2, 1, 0. When I taught economics, folks, I always used to give a 6-point quiz every week. That was the method of me making sure people showed up every week in my econ class. I didn't take attendance, so I just gave a quiz every week. And
I'm sure you have a lot of people fail.
yeah, not necessarily. Anyways, here are the scores, right? So I had 18 6s, 37 5s, 25 4s, 12 3s, 6 2s, 2 1s, and 18 0s. Because if you didn't show up, folks, then 0. I didn't care. There were no excuses that excused you from the 0 on the quiz if you missed a day. That's all there was to it.
What happens if you're in the hospital?
Don't care. Tough luck.
Oh, my.
Welcome to econ. I got tired of people giving me excuses. When their 15th grandma died again, I was kind of like, okay, whatever.
Was this a morning class?
It didn't matter whether it was morning, afternoon, or even a Thursday night class from 6 to 9. They all did the same thing. So econ's not all that exciting, folks.
I was running from class.
I liked it because I got to tell great stories, but better than these ones even, folks. I mean, I made it some great stuff.
Wow, you should write a book.
I really should. Okay, so, folks, mean, median, mode. And I double dog dare you to write them all out. And go slash, slash, slash.
I think I won't. But I would do that on the test.
And I'm assuming that you guys remember your math. If you have to add 6 to itself 18 times, how are you going to do that slightly quickly?
Multiply.
Multiply. Wow, see, you guys are smart. Right? So what's 6 times 18?
140.
What's 5 times 37?
185.
Wow, you did it like that? That takes so much time.
What?
I always just do parentheses, multiplication plus parentheses.
You can do that. It's okay.
And it takes so much, you know what I mean? Make yourself work smarter, not harder.
I agree.
I would do it that way. That would make sense.
Here's my question though.
Hmm?
No.
When you're adding up, well, when you're doing any of this, Do you include the zero?
I mean, you do, but what do they, I mean, what is 18 times 0?
I guess my point was more like if we're figuring out how many numbers there were.
Yes, the zeros
do you
count.
include the zeros,
Oh, yes.
So it still counts as 18.
Yes, those are 18 numbers that you are in the list, right? So, when you added them all up, what'd you get? 443. I'll buy that. Now, what do I do with the 443 to get the mean?
Divided by
7.
108.
Divided by 118 or 7? If you divided by 7, what do you get? Well, if you did, what would you get? You'd get a number like 63.
He's like, I don't know.
Would the
I didn't
mean,
do it, I was just guessing.
Yeah.
would the average of these numbers be 63?
Yes.
Because the numbers are between 0 and 6, so the average would be right. Please don't do that. That one particular type of mistake pisses me off, right? Because if you say the average of numbers between 0 and 6 is 60 something, you clearly are smoking crack.
Hey, some people like crack, okay?
So why is it 118?
Because I added up 18, 37, 25, 12,
Yes,
16.
add up your frequencies. That's the number of numbers. Sorry, what was that number again?
118.
118. So that's what you use to calculate the mean.
Plus 1.
443 over 118. Round to the hundredths just for kicks and giggles. 3.75. And yes, this is why lots of people failed my econ class, because the quiz average is basically a D. Because they didn't show up to class. It's like,
Life
oh.
choices.
I agree. All right, so median, folks. What's the number in the middle? First off, how many numbers are there again?
118.
What does that mean?
There's 118 numbers.
And what does it mean about the median?
That is
Yeah, that there's going to be two numbers in the middle. What are the two numbers in the middle?
It will be 59 and 60.
The 59th and 60th numbers. Yes, okay, good. So that's what we're looking for, right? We're looking for the 59th and 60th numbers. You just need to tell me what those numbers are, right? So half of 118 is 59. One more than that gets me to 60. So here's where you use the frequency table, right? The first 18 numbers are 6.
It's definitely not 6.
Definitely not 6. Okay, what's 18 plus 37? So the 55th number is my last 4, or my last 5, right? So 18 plus 37 gives you 55. So 55th number is a 5, right? What's my 59th number going to be? 4. What's my 60th number going to be? 4. These are both 4s. What's the average of 4 and 4?
4.
Hey, what do you know? 4.
I actually put that in my calculator. Had to make sure.
So this is why I gave you those position things in the median counter, okay? Because it makes it easier to find the median in a large set of data in a frequency table, okay? You can, if you want, write out all of those 118 numbers and go slash, 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 slash until you get to the middle. That's going to take a while, and you're probably going to screw it up.
We'll see.
Challenges.
I throw the gauntlet down to say give it a whack. And then last but not least, folks, what's the mode?
5.
5. Why 5? Yeah, because it repeated 37 times. So whichever number has the largest frequency, that's the number that is your mode. Okay?
Why the 4 plus? Oh, never mind. That's not. Just keep talking.
The median calculation. Average
Yeah,
feature number field.
I was, never mind.
Alright, so not bad?
No.
Okay, so there will be some homework problems like this. They don't use numbers as large as I do, though, so they won't be as painful. But that's a good problem, right?
Just fantastic. Yeah, it brought tears to my eyes.
I can understand.
We only have 22 minutes.
All right, so last topic.
Just letting you know. Heads up.
You really want to get out of here.
I want to leave so bad. I'm so tired.
Sorry. And I know that I'm going to go late. Sorry. Measures of dispersion. You should know what the range means, folks. What is a range?
It's a range of numbers.
So you go 0 to 6.
Well, but the range of a data set.
Oh.
Is the difference between the largest number and the smallest number. Okay, so a range of numbers is a range between, but the range of a data set is just the difference between the largest and the smallest number. Okay? All right, now here's where it gets a little bit funky, so bear with me, folks, okay? Please note that the book does not explain what variance is. I am going to use variance because it is the natural step that leads to standard deviation. So bear with me a little bit. I am giving you something here that the book does not present. All right? But it is actually a good stepping point to getting to standard deviation, so I like to use it first. Okay? The variance is defined as the average of the square of the difference between, not quite, between the data and the mean.
I mean, up would still work.
You could.
The average of the square of the difference of the data and the mean.
Yes, that's literally what the Webster's definition would be for what the variance is, okay?
It's the layman's term definition.
Well, I'll get you there. And then, last but not least, the standard deviation, which is what the book cares about, is just defined as the square root of variance. Standard deviation equals the square root of the variance. And everybody should know what that square root symbol means. It means the square root.
That one I know.
Good.
Couldn't help.
And note that is a standard button on your calculator. I'm going to expect all of you to be able to calculate the square root of a value. Okay? And in these specific calculators, the TI-30X2S's, note that the square root is actually a shift of the x squared key. Okay? So it's a little finagle work to make it happen. Alright? Alright, so these are our measures of dispersion, folks. Variance. What the hell does that mean?
It's when you're over or short on your register.
Alright, so what I am going to do for you folks is write the variance in statistical symbols. Okay? So remember, how did I write the average or the mean of data? What did I use?
Some alpha, zeta, some whatever it
It was a
That
sigma.
one, that
Okay.
over.
Yes. So since I'm calculating an average, folks, I have to sum things up. Averages are always sums. So I'm going to start with the sum of a bunch of numbers. Now, what am I summing? I am the summing of the square of something. I need to square something. What am I squaring? I am squaring the difference. What does the difference mean?
is. Like you can pick one number and another number and subtract that.
Subtraction. Good. So I'm going to subtract the data from the mean. The difference between the data and the mean. Okay? And then when you are done this, you are going to calculate the average of these things. Folks, there's a twist to what the variance is. Instead of dividing by the number of numbers, you technically divide by one less than the number of numbers. If you want to learn why you do this, take my statistics class next semester, and I will explain to you through an entire day's worth of lecture why you subtract 1. It literally is about an hour-long explanation to explain why you do it. I'm going to ask you guys to just accept it here in this class and do it for me.
Is there
Okay?
like a simpler way?
Is that
for you
class
to put
easier
that?
than
It's
this?
like that's not gonna
Oh yeah, this is
that's
the,
not
I'm.
gonna be helpful.
We're gonna do it in an easier way, but this is just the symbology that represents it. Okay,
So I was like, I was about to fail the whole portion that involves this on the test.
that's fine. I wouldn't ask you to do this, folks. Okay, reproducing this is silly. This is just the mathematical representation of it. Okay, and again, the reason why I show it to you is that lots of times people will write this out expecting you to know what it means.
You're like, nope.
I understand that that's not going to happen, so just realize I'm going to then deal with this. All right, so the way you do it, all right, so the best way to do these sorts of things is just calculate, right? So here's my data. Let's suppose my data is 1, 2, 5, 8, and then 10.
Thank you.
And I say compute the variance and the standard deviation for this data. Compute variance and standard deviation. Note that the book will only ever ask you to calculate standard deviation.
Oh, nice.
I would like you guys to calculate the variance because the next step is what it takes to get the standard deviation. Okay? So, the way you do this, here's my suggestion for how to do this. Create a table. Have 3 columns in the table. And the 3 columns are going to be labeled X, screw that, I'm not going to use the symbols. X minus the mean. And then the last column is just X minus the mean squared. Because those are the things you have to add up, folks, is this last column, right? And so what we're going to do is get to this last column, and when we have all of these numbers for every X, we can just add them up, okay? So, what you do in your table is you make a row for every number. So 1, 2, 5, 8, and 10. And the first thing you have to do is to calculate the mean. So somebody crank out the mean for me. I gave him a hint. I was very tempted to reach out and give them the one finger salute too, but I did not do that.
It's okay. My junior year of high school, my history teacher slammed the door so hard that he tore the handle off, and we were stuck in the classroom for like 2 periods.
All right, so first thing you have to do, folks, since you have to subtract the mean, is calculate it. So what is the mean of 1, 2, 5, 8, and 10?
5.2.
5.2?
That's what I thought.
All right. So what you do then is basically take each of your x's and subtract the mean. What is 1 minus 5.2? Negative 4.2. Please note, folks, that there's a negative sign there, but remember that we are going to square that negative sign. What happens when you do a negative times a negative? Goes away. So the negative sign is technically there, but please realize that when you square it, it's gone. Okay? What is 2 minus 5.2?
Negative 3.2.
Negative 3.2. What is 5 minus 5.2? Negative 0.2. And then the last two, 8 minus 5.2. 2.8, and last but not least, 10 minus 5.2, 4. Now, what I'd like you guys to do just for kicks and giggles is add all of those numbers up. Use the negative sign. What do all the negative numbers add up to?
You know, that never worked for me.
Is it gonna be wrong though?
7.2. 7.6.
All of the negative numbers add up to 7.6. What do the positive numbers add up to?
7.6. So
It's actually
0.
0. Folks, this is the definition of the mean. The old definition of the mean is the number that you can subtract from all of your data such that when you add up all of those values, you get back to 0. That's actually what the classic mathematician would use to describe the mean. Instead of saying add the numbers up and divide by the number of numbers, a mathematician would say that the mean is the number where the distance between my number and all the numbers to the left will be the exact same as the distance between all of my numbers that are from the mean to the right, added up. They will always be the same. As much negative as there is positive. That's actually the definition of the mean, old school style. Alright? So it's cool that that has to happen. Alright? Now, for us, we don't care because we're going to square those. So, what is negative 4.2 squared? Just get out your calculator. 4.2. You don't need to put the negative in, folks, because you know the negative is going away. Even if the calculator doesn't make it go away, you're smarter than your calculator. You know it will. Okay? 17.64. Awesome. Now do the same thing for 3.2.
10.2.
I can do 0.2. 2.8. Used to know that off the top of my head, but I don't right now.
7.84.
And last but not least, 4.8 squared.
43.04.
0.4.
Yes.
Awesome.
How do you use a square on this? With that shit?
Type the number in and then just hit X squared.
That's it?
Yeah. The square root is the one you hit the shape with.
Oh.
Because it's the one that's above X squared.
Mm-hmm.
Okay, so yeah, for X squared you just hit squared. Right, so you can type in 4.2, hit X squared, hit equals, bam. Alright, now, what am I going to do with these? Add them up. So add all those numbers up. Zero, carry the 2. 8, carry the 1. 8, carry the 1. 58.8. Alright, so we're almost there, folks. That's the numerator of our variance. What do I put down below it? 1 less than the number of numbers. How many numbers did I have? 5. So what's 5 minus 1? 4. So what is 58.8 divided by 4? 14.7. That's what our variance is. 14.7.
What does that X bar thing mean?
The mean. Now remember that's the variance. What else did I ask you for?
Standard deviation.
Standard deviation. What do I do to take the standard deviation?
Square root.
Square rooted. Exactly. So the standard deviation equals the square root of 14.7.
3.8340.
Let's round it to the hundredths just to keep it easier. What was that number again?
3.83.
3.83. Does everybody know how to use the square root on their calculator?
Yeah.
Alright? Okay, so that is how you calculate standard deviation. Okay? So whatever you have to write so that you can remember how to do this sort of table setup, write it down on your note card. Okay, folks? This is just something I'm going to ask you to do. Alright? Do you ever have to do this in the real world? No, you would make Excel do it for you, but it's a good exercise, and therefore I'll make you do it once. All right? All right, so, not too bad?
Will you just go down to that really quick?
Yep. That good?
So that's all you ever do is just find the square root of whatever the answer was for the variance?
Yep. That'll always give you a standard deviation. So when you do this, there are a few questions on the homework in the book that will ask you to do this, and realize that it won't ask for the variance, it just asks for the standard deviation, but you're going to have to calculate this number, 14.7, and then the last step is take the square root of that, okay? So they don't call this the variance, but realize that that's what it is, all right?
That's annoying.
And they don't want to burden you with too much information.
Oh, I'm sure of it.
I do, because I love the fact that you guys are learning more than you were supposed to. All right? Now, before you pack up and go, there is one last thing that I want to do, and that's show you why we give a shit about this. Okay?
Yeah, that would be a good one.
Okay, so why do we care?
Because our teacher said to care.
To some degree, yes.
And
Because
math
I have
is
to pass
fun.
this class.
True, passing is always a good thing. All right?
And math is fun.
Yeah, of course.
Brown.
All right,
Nice.
so
That was very cynical.
I didn't notice. I just assumed he was brown.
I'm sorry if I had too much of a smile, you know.
All right, so what we use standard deviation for, folks, is to describe the properties of a normal population. Okay? Standard deviation is used to describe normal populations.
I'm so glad because this is the reason why I took this class. So I could do this.
I feel like this is going to
So I could describe normal populations.
population control.
Well, realize, folks, that normal is anything that's describing human beings. Okay? We are, sadly enough, almost always normal. What that means is that if you're describing humanity, and you say, well, this one person over here is really weird, there will always be someone who is on the other side of weird and who is equal and opposite in the other direction. Right? Always. And that's what normal means, is that for everything that you have on one side, you will have another one on the other side that cancels it out. That's the way normal works, okay? And so the way it looks in a graph looks like a bell curve.
Like a what?
A bell curve.
Oh.
This will be on the test.
Okay, I'll watch the video.
Okay. All right. So the way the bell curve is set up is that it's centered about the mean. Okay? The center of a bell curve is always the mean. And what happens is that if you go one standard deviation to one direction, either way, right? This is x bar plus a standard deviation. This is x bar minus a standard deviation. What this will do will contain 68% of all of the population. Now, I'll explain what that means in a little bit once we actually use real numbers. But just bear with me for right now. All right? And then if you go two standard deviations, or subtract two standard deviations, x bar minus two standard deviations, this range of data, this range represents, not quite,
And then the next one's 100.
yeah,
I remember this.
95% of all data is going to be between two standard deviations of the mean. Now what this means, folks, is that if you have something where it's normal, and one of the most normal things in the world, folks, is men's shoe size. Okay? Actually, anything that's measuring people is going to be standard, based on all of the people in the world. Okay? So, What do you guys think the average shoe size for a man is?
9.5.
Well,
10.5.
It's somewhere between 10 and 10 and a half. All right. So the idea here is that the average shoe size for a man is 10 and a half, approximately. It's actually gotten a little bit bigger. It's getting closer to 11 in the last 3 or 4 years. Since I have to look this up every year, it's weird how it's actually getting bigger just a little bit every year.
That's weird.
Yeah, it is weird. All right, now, the standard deviation of a man's shoe size is about a size and a half. It's a little bit less than that, actually. It's a little bit like 1.4, but I like to have a nice even number, so I say it's about 1.5, okay? And what this means, when you have this information, first of all, men's shoe sizes are normal, with a mean of 10.5 and a standard deviation of 1.5. What this means is that here's the middle. Men's shoe size, 10.5. If you grab an average man off the side of the street, you would expect their shoe size to be 10.5, because that's what most men's shoe size is. Now, obviously not everyone is, right? Obviously not. But what it does say, if you add one standard deviation to 10.5, what shoe size do you get to? 12. If you subtract one standard deviation, where do you go down to?
9. Right.
And what normalcy means, folks, is that the percentages stay the same. So, folks, in the real world, 68% of all men have a shoe size between 9 and 12. Why would anybody care about that?
Shoe stores.
Every freaking shoe store on the planet cares about that, okay? This is how shoe stores decide how much to stock when it comes to shoe size. What are they going to stock the most of in men's shoe sizes? 9 to 12. If you have a shoe size between 9 and 12, you can be pretty assured that whoever's making your shoe makes your size, all right? Let's go with another standard deviation, right? If I add 1.5 to 12,
13.5.
13.5. If I subtract 1.5 from 9, or the other way around, 7.5. What percentage of men have a shoe size between 7.5 and 13.5? 95% of all men. That's what normal means. Once you get the mean and the standard deviation, this graph is the same for every normal population, right? The numbers down along the bottom change based on the mean and standard deviation, but the percentages are all the same, okay? And note, if you're out here on the outliers, if your shoe size is a 7, my shoe size is a 7. Guess how many stores carry a size 7?
Toys R Us.
Not very many, because I am in the 2.5% range of data, right?
That was mean.
It's quite all right. I only can wear toy shoes. I often go to the kids department. The problem
That's
with
what I
kids,
meant.
the problem with kids department shoes is that they're all narrower.
Wait, you're really a 7?
Yeah, I really have a shoe size 7. I buy my shoes on the internet because I can't find them in stores. I have really, really tiny feet. My wife and I have the same shoe size.
No wonder why you like your feet in 7.
All right, now note, folks. This graph is symmetric. What does symmetry mean? It's the same on both sides. Okay, cool. So, what percentage of men have a shoe size between 10.5 and 12? What percent?
So you'd have to take, if that's 68 in the middle, you'd have to find out what.
Half of
Half of
68.
68 is.
What's half of 68?
Okay, 34.
Thank you.
I had to do the math real quick. I couldn't just hold it out of my head.
And so, what percentage of men have a shoe size between 9 and 10.5?
34.
All right, now you guys are getting the idea behind symmetry. What percent of men have a shoe size between 12 and 13.5? This is a little bit harder.
This confused the hell out of me last semester.
take 95 minus 34, and that would give you that. No, half of 95.
What's half of 95?
Yeah.
47 and a half. So how much is in that other side?
34.
We're using up 34 of it. We're using up 34 of the 47 and a half. How much is left?
Sorry, I did the wrong one. 13.5.
13.5%, right? Because these two have to add up to the 47.5%, right? Half of 95. And so nicely enough, what's 7.5 to 9? 13.5%, because it's symmetric, right? Everything on one side has to be the same as the other. And what are the outside edges? What percent of men have a shoe size greater than 13.5?
No.
2.5. Why 2.5, Emily?
If that's 95, everything has to go up to 100, that's 5% less.
Uh-huh.
Split it.
Uh-huh. Because how many men have shoe size less than 7.5? 2.5%. Okay? And so this is how you use standard deviation, how business uses the standard deviation in the real world. Because this is how you stock everything. Every grocery store, or every department store that does anything that goes on to human beings, normal. Okay? Everything about us is unfortunately normal, folks. You'd like to believe that we're not, but we are. And again, the way to think about it is that for however weird you are, there is someone who is equally and opposite the same as you. And undoubtedly you run into them and you marry them, and that's how it works. Alright, so anyways, there are a few problems that on the homework to do this. Please note that I assigned some extra homework, right?
Yeah.
2 through 20, the evens on the normal section, and numbers 2, 4, and 6 on the optional, but it's not optional, you have to, section at the end of chapter 22. Okay? These are some extra work on standard deviation and using normal curves. Okay?
Lovely.
So you'll get a little bit of practice so that we can go over it on Tuesday next week.
2, 4, and 6.
Yeah.
You go up, little Marshall.
Yeah. So please note that Thursday next week will be our next test.
Thursday?
Thursday. Tuesday we will review. Thursday we take the test. The next week after that, Tuesday will be the review for the final exam. Thursday will be the final exam because there are now just 2 weeks left in this class.
Holy shit.
Yes, we are almost done, folks.
Damn,
So-
that went fast.
Yes, it did go fast. So, thank you for sticking around a little bit longer than normal. I'm sorry. I
Can I
know
ask you one question about the stuff you're writing down?
Yes,
You
sure.
got into the one section there, I don't remember, we were doing mean mode and median and mode. And you got into the one where you had all the numbers and then you got 4. You remember?
Mm-hmm.
You took the 2 numbers. I want to know how, I must have missed, yeah, there.
Mhm.
How did you come up, you took the 18 plus the 37.
Mhm.
Why did, that confused me for a minute there.
The last 5 is your 55th number.
See, I guess I'm missing something here. When you were trying to figure out the median of that numbers, the median is,
So the median is the 59th and the 60th number.
and how do you,
Because what's half of 118?
59.
It's 59. One more than that?
Oh, it's okay, so that's your formula then that you have,
Yeah.
plus that,
Yeah,
okay.
n over 2 and n over 2 plus 1.
Right, yeah, n over n plus 1,
Mhm.
okay. All right, that gave you the, because this is an odd number, or even number.
Even number because it's
So it'd be
118.
just average the 2 middle numbers, which is
Yep.
n2, and then n2 plus 1.
Right, n over 2, which
Right.
is half, and then one more than half.
Right, so that gave you 59 and 60, I got that part.
Okay.
But where did the 4? See, I'm still drawing a blank on the 4. And how did you get the 55th number?
Is a 5. Is the last 5. So what's the 56th number?
See, this is where I'm trying to figure out what maybe I'm overthinking it.
So how many 6s do I have? 18,
18
right?
sixes. Okay. Okay.
You get the idea, right?
I get the idea.
There's
Okay.
18 of these. Right?
Okay, so what you're saying is, what numbers, if you go from the top to the bottom, get as close as you can to
Yep.
that. So technically, then 56 would be a 4.
Yep. And the 57th would be
Another 4.
another 4.
So 59, 60 would be 4 and 4.
Exactly.
That's
Because if you add 25 to 55, you're going to get to the 80th number.
Right.
And so 59 and 60 are both between 55 and
So
80.
then you put that over. Where did I get that?
So then you just average the two 4s.
So, but see, it was average the two middle numbers.
Right. These are the two numbers in the middle, 4 and 4. How do you average 4 and 4?
Right, it's 4.
4 plus 4 over 2.
But see,
Just-
that's what I don't get, the middle numbers. The middle numbers is 59 and 60. You add those
59th and 68th.
59th number.
Yes.
There,
There's
that's
the key.
Thank you. That's where I was drawing a blank. So
Yeah.
59th and 60th.
That's why I wrote to the
60th
Yes.
number. That's
Yes.
what I missed. Okay. So the middle numbers are 4s. Okay. See? Now I got it.
Okay,
All right.
cool.
All right.
Yeah, it's one of those where once you see it, you're like, oh!
Yeah, no, so
Yeah.
click the TH.
Yeah, it's the. Oh,
Right,
I was not
right,
enunciating.
right. Okay. And I still don't see where I'll use it. But no, that's okay. It's better than having to take straight algebra, because I'll never use that.
Oh, Greg.
Well, you know that you do, because you teach it.
Well, yeah.
Okay, tell me how many times you use true algebra in the real world. I'm sorry, 42 years in the business? I mean, I don't think
Well, I mean, if you're trying to figure out how many miles you can go when you have to, when you're when you have a 15-gallon tank and you get 22 miles to the gallon.
But see, that's
how-
just straight math.
Oh, no, that's algebra.
Oh, that's math.
No, that's algebra.
Really?
You just don't believe it's algebra because you think it's too easy.
Yeah.
But it really is algebra.
It's just a fancy word for reading, writing, and arithmetic. You know,
Arithmetic.
3 R's.
The 3 R's. Take it easy, Greg.